All right, in 7.4, Part A, we're going to look at dot products of vectors. So let's look at the definition of a dot product. It says the dot product of U, which has components U1 and U2, and V, V1, V2, is this. So this is what the dot product symbol looks like. So notice what's happening. It's U1 times V1, so it's the X components multiplied together, plus the Y components multiplied together. And so it ends up being a number. All right. Properties of dot products. Let U, V, and W be vectors in the plane or in space, and let C be a scalar. So let's just kind of look at this here. Properties we know. U times V is the same as V times U. All right, V dot U. It's just the same as our multiplication properties. 4 times 5 is the same as 5 times 4. Okay. Number 2, 0 times any vector gives me 0. Number 3, this is the distributive property. U times V plus U times W is the same as this right here. 4 says V dot V is the magnitude of V squared. And then this, remember, C is a scalar. It's not a vector. Scalar times the dot product of U times UV. So it's also equal to the scalar times the vector U, dot product of V. Or it's equal to U times the scalar of the dot of times V. It's a mouthful, isn't it? So just keep that in mind. We don't see this a whole lot in this course, but it's just a property to know. So let's try some of these, all right? Finding the dot product of U and V. U is -4, 1, and V is 5, -4. So dot product, remember, come back up here. What are we doing here? We're multiplying the X components, and then we're multiplying the Y components and adding them, okay? So if I multiply the X components, U dot V would be -4 times 5 plus 1 times -4. So what I have -20 minus 4, so that means I have -24. And there's my answer. Now that it's a number, it's no longer a vector, we call this a scalar. All right, just like we did with C above, okay? What about this one? This one's given to us in linear combination form, so we can rewrite it in component form as 2, 6 and -3, 7 first, okay? So if I do U times V, what am I doing here? I'm going to do 2 times -3 plus 6 times 7. So that's -6 plus 42 gives me a 36, right? And that is now a scalar. It's no longer a vector, but it's a scalar. Let's try these. Use these vectors U, V, and W to find the indicated quantity. State whether it is a vector or a scalar. All right, so let's look at this. Dot product of V times W. So I have -5, 3 times 1, -4. Okay, so -5 times 1 plus 3 times -4. -5 minus 12 gives me -17. And now I need to do the second part. Is it a vector or a scalar? Well, it's no longer a vector, it's a scalar. Okay, two-part answer. Number 4. 4 times U was 2, 2, dot product of V, -5, 3. Okay, so I need to do this part first. So 4 times U would give me 8 and 8. Then I do the dot product. So 8 times -5 plus 8 times 3. So it's -40 plus 24 gives me a -16. No longer has two parts, so it's a scalar. All right, let's try one more. U times the 2V times, so this is a dot product, times W. So let's take care of this part in here first. So what does 2V look like? Well, 2 times V is -5, 3. So 2V is -10, 6, right? All right, so now it's asking me to do the dot product of U times -10, 6, okay? So if I do the dot product here, I'm going to have 2 times -10 plus 2 times 6. -20 plus 12 gives me -8. And now I need the next part here. I take that look, that's become a scalar. So now it's negative 8 times the vector w, which is 1, negative 4. So I have negative 8 and a positive 32. Okay, look, we've kept the vector notation, so this is a vector. We just multiplied a vector by a scalar, and it's still in vector form. All right, let's look at the back. Now, one last thing here. We want to find the angle between two vectors. What the heck does this mean? Well, let's say here's my coordinate plane, and I have a vector here, and I have a vector here. If I want to know this angle between them, that's angle theta, and I want to find that angle between those two vectors. So here's the formula we're going to use. It's the cosine of theta is the dot product of uv over the product of the magnitude of u times the magnitude of v. Okay, so we're going to end up using cosine and inverse cosine to find that angle. So let's do number 6 here. All right, let's do this in steps. What do I need first? I need the dot product of uv. So u times v, or dot product of v, is, let's see, 4 times negative 2 plus 4 times 0. That's going to give me a negative 8, right? Okay, so I know it's negative 8. So I'm going to come down here. Cosine of theta is going to be negative 8 over something, right? All right, let's do the magnitude of u would be 4 squared plus 4 squared. So 16 plus 16 is the square root of 32. And then the magnitude of v, negative 2 squared plus 0 squared. Well, that's just going to be a 2, isn't it? Now, if I clean this up a little bit, I know that the square root of 32 is really, what is it, 4 times 8, which is 4 times 4 times 2, right? So I can take a 4 out. So that'd be 4 square roots of 2 times 2. So if I clean that up, let's just clean it up a little bit. This will be 8 square roots of 2, right? So if I cancel those 8s, I have negative 1 over the square root of 2. So what do I have? All right, I have cosine of theta is negative 1 over the square root of 2. If I rationalize that, what do I get here? Well, I get negative square root of 2 over 2, don't I? So the cosine of theta is negative square root of 2 over 2. Now, stop and think. Yes, I know you can use your calculator here. Let's think. This first vector is at 4, 4. So that's over here. There's u. Second vector is at negative 2, 0. So it's going this way. So I'm looking for this angle between them. I can tell it's an obtuse angle, can't I? So what is the cosine of, what angle has a cosine of negative square root of 2 over 2? If I do this in my calculator and I say inverse cosine of the square root of 2 over 2, I find that theta is 135 degrees. And that makes sense when I look at my picture. It should be an obtuse angle. All right? Let's try number 7. Feel free to pause the video, try it on your own, and then check it, or just keep watching if you need more instruction. All right, so let's do our vectors first. So for j, if I rewrote u as a component vector, remember it doesn't have an I component, so that means it's 0, 4. So that's 1, 2, 3, 4. So it's up here. There's u. And j, it has a horizontal component of negative 9, 0. So negative 9 is way out here. All right? So I'm looking for this angle right there. Can you predict what that would be? Looks like a right angle, doesn't it? Well, let's just see if we run through the math if it turns out to be a right angle. All right, so using what we know, the first thing we have to do is the dot product of u times v. So when I multiply these, I have 0 times negative 9 plus 4 times 0. Well, that's just 0, isn't it? So if I do the magnitude of u, let's see, it's going to be 0 squared plus 4 squared. Well, that's just going to give me a 4. Magnitude of v would be negative 9 squared plus 0. When I take the square root, I get a 9. So then Theta is the inverse cosine of 0 over 36. Well, that's just 0, right? So where is the cosine 0? Think about your unit circle. Where is the cosine 0? It is at 90 degrees. So feel free to put that in your calculator of inverse cosine of 0, but you're going to find out that that angle is a 90-degree angle, and it does make sense when you look at it, the picture. All right? Hope that makes a little sense. Let me know what questions you have when we get to class.